for the planter with climbing plants and sensor installed at a depth of 15 centimeters. So with this type of information, we can identify the difference that exists between the development and the demand of plants of the same species, and evaluate which criteria we will adopt for the irrigation settings for the standard and thermal stress scenarios. So for example, we can choose less 60 kilopascal to start the irrigation in a standard thermal in standard scenario, or less 30 when it's a stress scenario. We are working on it now. And also we will work with the correlation between variables and relate the reason that explain the different results obtained in the different locations of the study area. So as an example, we have here the shade dynamic in the pilot, the air temperature and the relative humidity for the 27th of August at 18 o'clock. And for the same day, here we have in this image the thermal comfort index in 8 points of the pilot. So here we have 7 points, so these 7 points indicating a category of stress of strong thermal stress, and 1 point that we have another category that is very strong thermal stress. So I emphasize here the attention that we should give to the way that we expose the results about the impact of the vegetation and irrigation, because we have a wide diversity of indicators. For example, we can talk about the impact in air temperature, surface temperature, and temperature equivalent to the thermal sensation. So when you talk about a pedestrian scale, you must speak of temperature equivalent to the thermal sensation. So in this case, the UTCI index. So with this kind of information, we will try in the next campaign of the summer this year to verify the impact of the different irrigation actions on the study area, the duration of its effect, and the spatial extent to which it's felt. And as a conclusion, finally, in this presentation, we reveal some concepts and methodology from my PhD project on the use of irrigated vegetation to mitigate heat waves in cities. The aim of this study is to contribute to the understanding of the complexity of the urban metabolism in order to act in a more effective way. There are a big challenge before generalizing the experimental results, since they refer to a particular case of climate, temporality, and situation. However, the experimentation is essential to understand and learn about this subject. And finally, it is therefore interesting to combine experimentation with numerical model, as this allows us to produce more generalizable results and to compare different scenarios. Thank you for your attention.
Thank you very much, Martina, for your presentation. I can open for questions. I do have one question, actually, but I take the opportunity to ask it first. Do you have the same like, are you engaged with other institutions? Because we have actually the same problem and the same difficulties and challenges in many other cities, not only in Paris. Is there any integration of efforts, academical efforts between different cities, or you do it separately within the AgroParisTech, only in Paris?
Our pilot is in Montpellier, in the south of France, and we try always to exchange with the other university about the subject, but we work separately. So, for example, in Angers, there is another pilot that works with a tree, for example, but we try to exchange, each one doing some project and experimentation.
Okay. Thank you. Good. Do you have any questions to Martina? By the way, it's good. It's going to be until when? Yeah, please go ahead.
Martina, could there be an effect of the amount of captors you have in one planter? Because it's quite small planters in your pilot. And so it takes place, the captors, and does it generate heat too? I don't know. It's a question.
Yes.
Could there be an effect?
We're seeing some interesting things. For example, the temperature inside the planters is really hot. So this have an effect in the dynamic of the planter. So we are trying to understand how this works and how this impacts, for example, the evapotranspiration, and to also adaptate our model, because OptiRig is a model that works in a traditional context. So we are changing the model to the reality of the city and planters, and we see that there is an interesting impact also in the position that we introduce the captors. If it's near a plant that is well developed or not. So yes, I think it was this your question. But also we can exchange more, because we are talking also with Thomas. Yeah. Now we have more results to talk about.
Okay, may I ask a question? Bruno Moll is speaking. Yes. Well, regarding the experiment on the pilot, it is really interesting to have this kind of experiment in controlled conditions, as when you work in real world, it is very complicated to have such a density of sensors, and the quality of information is very interesting. But the problem that you face is the size of the pilot of this experiment. But it seems that the effect of UTCI is noticeable. But how do you manage to avoid or to understand the border effect? Because if we observe the slide, the four last slide that you have shown, we see that there are green lights somewhere, and just around you have red or orange lights, which means that the temperature is very high. So how do you manage it? Or is it something that you will use to better understand what happens?
I think we will have more elements to conclude about this in the next campaign, but I believe that we are close to the real scale, because we are talking about the effect in the pedestrian level. So the effect of the plant and the irrigation, they are really close to the plant. So I think that this problematic of the scale is something that we will face in a real scale also, and it is part of the problem. So even though, for example, as I show in the results that you had in August last year, we have a small scale zone, and even though we have different category of stress. So what I think is interesting is see the fact that we have with our irrigation in the change of this category of stress. Because if we change, for example, 4 degrees, maybe that is not effective to change the category of stress, and so the impact is not really important. So is this kind of question that we will try to work better in the next campaign and try to understand.
Okay, thank you.
Thank you. Another question, maybe?
Or comment.
Or comment, yes. Okay.
I think we're good.
Yeah. So maybe we can move to the next part of the forum, the innovation and technology session with Coralie.
Just to thank Martina for your presentation. We're going to share the presentation and the website, if with your permission, of course, Martina, and with your details as well, so people can take contact directly with you. This one.
Okay,
So
perfect.
thank you very much and good luck with this.
Thank you.
Please go ahead, Flo. Sorry.
Yeah. So,
and you are invited to come further to present the final results in 1 year and a half, more or less.
Yeah, it's 1 year and a half. We're waiting
with the model.
Sure. Thank you.
That's a good deal. All right.
Yes, so we are going to move to the latest part of the forum, the innovation and technology session with Coralie Tavassoli from Urbascience, and she will present us agronomic reasoning of trees watering in the city to facilitate their cooling effects. So I will share the presentation now. Okay. Okay, we can start if you want. Coralie.
Thank you, Claire. So I'll present the way to adapt the trees watering to facilitate their cooling effects, and it's quite the operational objective of Martina's study, in fact. So how does we reason the trees watering? We measure first the water reserve for roots, because when you have no roots in the soil, you always have water. You'll have maybe a few less inches of water in the soil, but it will always be quite full. Next, please, Fla. There. So when you have no roots, there still is water, even if you have a lot of sun. But when you have roots in the soil, the roots are strongly drying the soil, because it's a strong effect of pulling water off the soil. And we can put tensiometric probes in the soil, so it will detect the drying of the soil. And then when you have a high drying of the soil, you have root activity, because when you have no root activity, you don't have this high drying effect. Next, please. So when you detect the root activity, you can also detect the root growth. How? Well, it's with different probes. You have several points of measurement. You have here for grass, maybe 5 centimeters, 10 centimeters, 15 centimeters. And you will see drying on the first 5 centimeters, but not at 10 centimeters first. And then with time, you'll see that at 10 centimeters, it will start to dry. And then at 15 centimeters, it will start to dry. So you can measure the root development and the root growth. And you can also influence the root growth with the amount of water you keep available in the soil. So you can force the roots to grow in a certain direction when you have no water available where the roots are, and you have water available a bit further, so they will go where the water is. Next, please. Nowadays, we have different ways to conduct watering. You have the calendar method, you have the ETP compensation, you have the root water reserve. What we use at Urbascience is root water reserve. What is the the difference is that you have a possibility to grow the roots deeper, and you have the ability to optimize the water consumption, maybe better than when you just use a calendar method or ETP compensation. Because with calendar, you don't really measure the water consumption. You just say, I'll water my plants every 2 weeks. And even if they don't need it, they'll have to be watered. And when you have ETP compensation, you'll be better, but not maybe the best you can be. Next, please. So this is what we measured, is that calendar-based is the basic method. When you go to ETP compensation, you have 20% of water compensation in less. You keep 20%. And when you go to roots-driven watering decision, you have 30% less use of water. So it's a big difference. And you can have a well-maintained watering system with no leaks and no heterogeneity. So it's another part of the watering decision that will help the people watering to use less water, because you all know that water is, you have less and less water available. You will have to take care of this water resource. And so every action we can make to use less water is good, and we have to work on it. Next, please. Yes. So this is how we work. This is our data cycle. We have a tree in the center of this image, and you have 3 or 6 measuring points that are connected to a device that sends the data to a web server. And on the web server, we can have access to the data, and we analyze the data and we'll tell if we need to water the plants or not. So we take the watering decision based on the data of the projects we are following. Next, please. So we need to have data-driven decisions. So we have raw data that is taken from the site, from the plants in the cities. We'll have a refined data with, we can input a lot of data to this raw data. We can have the emplacement in the city. Is it on a high driven pathway? Is it a difficult site? Does the tree cost a lot of money? We won't take the same decision if we really need to keep the trees alive, or if maybe we can afford to lose maybe 1% of the trees. And with this refined data, we'll take a watering decision. This watering decision is going towards a watering system. A watering system, it doesn't matter what watering system it is. It could be integrated watering system, but it also could be manual watering decision. Well, for us, it doesn't really matter. And we have a retro control, because we can see on the data if the watering is correctly done. Is it not done? Is it not efficient? And if it's not efficient, the job is to check why and to have a more efficient watering the next time. So it's really important that on this data-driven decisions, we can have interoperability between all the boxes you see here. so we can have all the information in the same place to take the good decision when it's needed. Next, please. So we'll go towards the vegetal use. So a tree, the vegetable, the tree absorbs water by the roots, and it stores the water in the tissues. 5% of this water is used for metabolism, so it's photosynthesis, it's sugar production, but 95% of the water is used for cooling. So you have a huge potential of cooling effect by the tree. One oak during summer, it's 500 liters evaporated per day. So it's a daily electrical consumption of 2 families with air conditioner. So it's huge. We can't have an electrical device that is as performant, as efficient than a tree. So we'll take the tree as a tool and we'll use it to cool. So how? Next, please. We have an experimental site. It's Garibaldi. It's a French avenue in Lyon, in France. And on this experimental site, we are measuring what effect does the vegetation have on cooling and what contribution on specific watering we can have to amplify this effect. So we want to cool as much as we can and to see how we can do it. Next, please. This is a quick description of the site. I'm sorry, it's in French, but I'll explain to you. Before, this avenue was a road and a bridge, and it was made differently, and we had the opportunity to construct something new. So they thought about a new system with water ponds underneath the streets, and you have the water from the walkways, the pathway, and the bicycle ways that go in that pond. So you keep the water from the street, and you can reuse the water to water the trees that are planted on the street. You have 2 separate parts on this street. You have one part with irrigated systems, integrated watering systems, and you have one part with no irrigation. So we can compare the 2 parts. Next, please. You have all over this avenue sensors and actuators. You have thermometry. You have the measurement of the thermal attenuation. So it's in the air. You have a microdendrometry measuring point sensor that will allow us to measure the cooling effects, because it measures the evapotranspiration of the trees. So it's in the tree. And you have tensiometry, so in the soil by the roots, that will allow us to measure the efficient root activity and the hydric comfort of the tree. Next, please. All this data is processed by an algorithm that we call phytocooling, and the algorithm will take the decision to water or not water, and will emit a watering program. So this watering program is going to the irrigated trees. And in the part when there is no irrigation, there will not be any water. So the data that we submit to the algorithm is tensiometry, the retention pond level, the provisional meteor, the UTCI, so it's the comfort index that Martina presented earlier, and the microdendrometry. Next, please. What is the watering process? We have on the site self-regulating drippers, and we'll water 3 hours per night during 1 week, because we really need to water the whole soil where the trees are. We saw that we have an inertia of 3 days. So it means that when you start watering, you won't see the cooling effect before 3 days. So we need to take advance on the heat waves so we can have the better cooling effect as soon as the heat waves start. The other option that we did not have in this experimental project, but that could be tried, is flood irrigation. So it means we put like the whole amount of the retention ponds, we open the valves and it goes to the soil. It could be an option. In this particular experiment, sprinklers are not an option because it's a public avenue and you cannot use non-potable water in front when you have public. Next, please. Here are the results that we have. During the heat wave of August 2020, we had 3 principal measuring points. So in green, you have the measuring point of a pole in between the trees that are not watered. So it's just the effect of the tree being here. In red, the curve in red is the temperature on a pole where there is no trees at all on the street. And in blue, it's the temperature on a pole between the trees that are watered with the irrigation system. So you can see that on average, compared to so the reference where there is no tree is a candelabra, you have the trees alone, you have 0.43 less degrees, and when the trees are watered, it's almost 1 degree less than the average temperature. So you have a huge increase in cooling when you have watering systems. We saw this data and we thought it's not as much as we anticipated. We thought it would be better. So we had a few adjustments because we measure the air temperature on a pole that was at 7 meters high in this experimentation. And in fact, there is no human as high as 7 meters. So it's not a good measuring point. So next year, we had a measure point at 4 meters high. Next, please. And on this heat wave, so in June 2021, the trees watered, it's 1.1 degrees less than average. So I think it's better. We'll still have to find the best way to monitor the difference on air temperature, but it's quite obvious that you have an effect when you water the trees. You still have an effect to only have trees on the street, of course. When you are walking under the trees, you feel less the heat than when you are on mineral street. But when you water the trees, you can have a double effect of the trees that are already in place in the street. Next, please. So the really important point is that we are understanding the plant's needs to save water. We only water the plants when they need it. There is no interest of watering the plants when the water reserves in the soils are already full. You're just wasting water. And you can have enough information on the plant's needs to use the water you put in the soil to have a real effect. And it's not, the effect is not only to have a fully healthy plant and to make it beautiful. The effect could be really cooling their environment. And it also could be a health concern because you have the possibility to choose when you will water, so it can have this double effect. For example, you have two neighborhoods in the same city, and you are in August. It's 40 degrees outside, but you have a quite rich neighborhood. There's maybe 10% of the population that is still home because the others are in vacation, maybe in Puerto Rico. And you have another neighborhood, quite poor, with 95% of the person still in this neighborhood because they can't afford to go in holidays. And you will maybe start to think to water the plants in this poor neighborhood, because when you water the plants in this neighborhood, you will have 2 degrees less of heat in this neighborhood, and you take care of this population that does not afford to go somewhere else during summer. So it's beginning to be a health concern, a political decision. You really have keys to take another kind of decisions. And how will we start to put these solutions in place? Is that opening systems to data-driven decision. You have to take the data from the site you're monitoring. You want to water some avenue. You have to take data from this avenue to take the right decision. Next, please. So that will be my conclusion. You always have to balance the artificial intelligence. So it's the integrated watering systems. It's artificial intelligence. And how will you decide to open it? It's with natural intelligence. You have to take the information from nature to give the right decision. That's all for me. Thanks.
Thank you.
Thank you, Coralie. Now I'm going to wait with my questions because you can imagine I've got some. It was very interesting. Thank you very much for very interesting and very much aligned with the previous presentation. So well done on mitigating everything, Bruno. Like we have the same, the same. We keep the same topic today. Any questions or comments from the audience to the presentation of Coralie? So I will start. I really have some important things because you mentioned Coralie, if I may. I really like the storytelling here. The storytelling is very good because we are. First of all, you started with saying that you're taking the operational side of what Martina was presenting. So you're basing what like the first step on the implication of operational realization of the models. That seems to be sometimes very high level, a pie in the sky, and that's a beautiful thing that we see. And I wonder how you're gonna take this forward, because I guess that you said that you don't mind if it's gonna be watering by hand or with a hose or with a sophisticated system or whatever, as long as it's not sprinklers if we use gray water or so. But anyway, it's so did you think about how to continue, like the automation of this system in terms of you have a line of trees, so one tree will be watered in this way and the other one, like this is really precise watering that you're going to, right? So you need to have also the hardware. So I don't know if you thought about this and how to connect this to automation or whatever.
Well, in fact, we thought about a lot of things. We would like to try everything. Well, we can't, so we'll take step by step. We already have integrated watering system, so it's opened from our server. So that's a first step, but the system that is in place is already there. We won't change it. So we can't really try something else, or it could be on another experimental site. We would like to. We have other opportunities that are not in place yet, but we would like to try it.
Okay, that's important call. There are some people I know here in this forum who are dealing with irrigation as well. So maybe that's going to be a nice cooperation in the future. Second question, because you also touched the storytelling. It was you also arrived to the social part of the storytelling about the neighborhoods and everything, and this brought me to think about is there a special reason why you did it in Lyon? It's because of the political green situation in Lyon today. Like, do you need maybe a word about the cooperation you're looking for? What kind of collaboration you have with municipalities, with la métropole de Lyon, for example?
Yes, in fact, this project, the first step of this project is a European fund for interoperability. So we had money from Europe to do this. And then a part of this project was financed by the Grand Lyon, so it's the metropole.
Yeah.
And now it's funded by, the money comes from Lyon. So that's why we did it in Lyon.
And when you are in touch, when you're talking with Lyon, with the representative of the metropole, for example, the considerations, the importance of what you're doing is about as you mentioned, the balance, the energetical balance to get there, like to get to a solution that you can do the calculation, how many kilowatt you spare by pooling, what you gain, what you earn, what you pay, and so this is how you're trying to build the case here.
Yes, we try to conceive to have the city we would like to live in tomorrow, and how we will use water in this new city, and to have the better use of the water we can. So we have to measure the real benefit of the water we put in the soil. If there is no benefit to water the trees, we won't do it. That's the real point. It's an economical question too, because it costs money to water the plants, and when you do it, you have to see the results.
Yeah, exactly. And the mortality and the cooling effect and everything else around this. So it's not only beautiful, it's also energetically wise.
Yes.
Okay, that was my side call. I told you I've got many questions now, but I see that Damir has raised his hand. Damir, please open your mic.
Yes, I did. I have a question for Ali. During the experiment, did you try to consolidate data about water consumption or the difference between water that was applied to well-irrigated trees versus non-irrigated when you were recording the temperatures around the trees? Did you somehow try to extract the data regarding volume of water that was applied to those trees, and how did you do that?
In fact, we do have the data because we have the level of the retention pond, so we can know how much we used. But I'm not the one conducting this project, so I'm not sure they they used this information in some way. I know we are trying to see the difference when we put a lot of water or just a few liters. That's something we'll do next year to really try to see the difference bonded to the amount of water used, but we're not there yet. We'll have to continue searching for this.
Because it seems that here we are talking about already grown bittersweet tree species.
Yes.
Which are usually considered not needy of irrigation, right?
That's
so
true.
It would be interesting to understand what is that, because we know from available information what is generally the water requirement of new trees. But when we are talking about mature trees in cities and the water need for keeping them healthy and keeping them maintaining that cooling effect, this would be something interesting to understand.
I agree. We started working on getting the soil to saturation. That's how we worked first. And now we saw the effects, and we have to try different methods now. Other questions?
Yeah. Yeah, I have one. Well, thank you very much. Really interesting and really complementary with the previous. What you have shown in terms of variation temperature is a little bit frustrating, and in terms of absolute value, but when you have say that the temperature was measured at 7 meters from the soil, I was not surprised to see this result. Yeah. And on the other side, I saw the experiment of Martina, where she is measuring at 1.3 meter. As far as I know, this is a standardized temperature, 8. And my question is for both of you. I know that Martina will put a number of sensors on the same site that you have presented. And do you intend to analyze or measure the temperature profile that may be of real interest in this case?
Well, I'd love to. Our problem with the high was that you have people walking on this avenue. So as soon as it's well, people can touch it, you take risks with your sensors because they will touch it. So that's why we have to be as the better we can do is 4 meters, and that's a bit high.
Still, people cannot touch it. Yeah.
Yeah. I'd love to have a temperature at 1 meter or it's 1.3 would be best. I'm not sure it's we can do it here.
Okay, and this is temperature, not UTCI.
Well, we have both, but it's the results are more obvious with air temperature than UTCI, but I do have UTCI values if you want to see it.
Okay. Thank you. Any more questions? Sorry.
Martina, what will be your protocol in this site?
Yes, I think this is the interesting of having a pilot, because we have a liberty to put the sensors where we want, and we take into account the reference height related to the gravitational center of a person, because is this the recommendation for this kind of index? So also depends of the height of the population, but we take into account this high because of to be near of how we feel when you place near the plant. But I know that it's difficult to do this in a real site.
Thank you.
All right, any more questions, comments? 2 presentations. If not, let's first of all thank you again, Martina and Coralie, for both of you for beautiful presentations all around, well linked together, eye openers for many things. I think that I took myself some notes. I saw that Marie-Laure as well. She took some notes here on the things that we find interesting. Because it all comes together with measuring and with getting into the quantified results shared by not only by companies like private companies, but also with the research around. And so I want to go to the next level of really using data not only for decision making, but also to show what does it mean irrigation. Irrigation, even in the city, when you irrigate a tree, it doesn't necessarily say that you are wasting water. Of course, there are many nuances, but this is the kind of these are the conversations we're trying to get in on how to measure the value of what we do in irrigation. And of course, you can imagine if it works for a tree in the city, it can also work for other crops that we're dealing with in parallel. So these are the things that we're trying to do. And thank you very much for this for an introduction. Closing session. I'm sorry, we have the hands raised by.
Yeah. It's me, because Mr. Alexandre Boudon arrived in the forum, and maybe he can introduce him and Green Citizen.
He can just join us. So we still have a few minutes, so he can join us and say hello and show his
and show his slides.
Show us up, Alexandre. Hello, Alexandre.
Hello,
Alexander, I'm sorry.
Okay, so sorry for being late. So just to introduce Green Citizen, so we are providing solution for digitalization of water networks operations, and our customers are managing sanitation, rain networks, green space in irrigation, or access to drinkable water in for vulnerable populations. So, can you go ahead, please?
Yeah.
So we are providing a smart watering solution for smart and sustainable cities with 3 major benefits. So water savings, so from 30% to 70%. We save also field trips for the gardeners, and also we participate to the cooling as Herbasense show you. Can you go ahead also?
Yeah.
So in the last 2 years, we help these cities to make huge water savings. So from 35% to 74%. And maybe go on the next one.
Yeah.
Yeah, so we have a full automation of the process. So we put some soil probes at the root level, and we automate the watering only, and we water only when it's relevant. So we have a special algorithm to automate the watering without any manual watering.
Okay.
And that's it.
Okay, thank you.
Thank you. Did you enjoy the presentations before, Alexandre? Have you been here?
Yeah, we already know Herbasense.
Yeah, I guess. I was guessing so. So welcome to the EIA, to the association. We're glad having you with us.
Thank you,
Alexandre.
Thank you.
And good luck. So now it's okay, Fleur, to close the session.
Yeah,
Okay, good. Good. So actually, at this point, usually we just let the microphone is open. If any one of the participants has anything to add or to comment or to suggest or to improve or to complain or
just one comment or one information.
Or okay.
One information. I just put back the link for the survey that we are conducting on the question of taxonomy that you have presented in the introduction of this session. And we need to know what is the interest of the members, of the non-members, because as Moshi said, if irrigation is not in the taxonomy, it will be considered that irrigation is not able to support sustainability and is not accessing any green bonds. So you have to wake up professionals on these questions, please. That's it.
That's a very valid and comment. Thank you for adding this, because I forgot to talk about this. And obviously, this is what drives our excitement today, because we really understand that we need now it's the exact moment that we need to take the Green Deal and the CAP and the taxonomy and to bring everything together and to bring the water that we don't talk about water and irrigation and anywhere in Europe today. It's not part of the game. And we see, especially in France, which I know better, we see so many fights about water, around water and the bassin and everything that today is around the same aspect. And we need to show what we can do. We need to show that the irrigation is not just pouring water everywhere. We need to show that we have the technology and the savoir and the know-how and everything around this, and the technologies, the hardware, the software, as a sector, and to raise the hand and say we are part of the solution, because for us it's obvious, but surprisingly enough, we don't see it in many other places, and that's really pity, and it means that there is a lot of lobbying to do, and there is a lot of work around this. Professional work to be done. But as I mentioned before, stay tuned, because this will be exactly the part where we will try to contribute 50 cents here as an association, and hopefully we can contribute something to the promotion of the status of the irrigation sector in Europe. And as we already said, as always, it is basically we are leaning on the membership willingness, sometimes happiness, I don't know, to participate. That's the way we work today, and we keep on calling members and non-members and visitors to join us. You can join the working groups. You can join the work. Each one is setting his own pace. Not too much work around it. We are all we're having our daily jobs here. So, but we all share the same passion on trying to do something together for the best of what we're trying to do in our daily life and professionally and personally. So I'd like to leave you with this and to thank you for the participation today. The microphone is still open. If anyone would like to add anything, you're more than welcome. I'm just a feeler, so I keep on talking. That's my job. All right. And if not, while we're thinking about this, I'd like first of all to thank someone deactivated me. I understand. But so thank you, Fleur, for this.
Thank you.
For running this. Thank you very much, Bruno, for arranging the two topics together. Of course, thank you, Martina and Coralie, for your well-prepared presentations. We will share the presentations later on our website. And I wish you all a very nice afternoon and almost the end of the week. Thank you very much for your participation. The forum is closed. Thank you.
Thank
Thank
you.
you.
Have a nice day.
Thank you.
Bye-bye,
Thank you,
everyone.
everyone.
Bye.
Bye.
Bye-bye.
Bye-bye.
Bye bye.
Bye.